Hello,
And welcome to our video on livestock housing,
specifically focusing on pig housing. This video is part of the course ABE 324, AB Structures Engineering. The Philippines relies heavily on domestic swine production for national food security, providing 60% of the Filipino population's total animal meat consumption. It is ranked 8th in the world in terms of the volume of pork production and number of breeding sows.
However, the industry faces challenges such as the continuously increasing demand for pork, the struggle to supply feeds for swine production, and the prevalence of the African swine fever, ASF. To address these issues, DOST-PCARD supports R&D initiatives aimed at improving productivity and production efficiency, creating new opportunities to increase the overall competitiveness of the Philippine swine industry.
So today we'll be discussing Chapter 10 Livestock Housing, specifically for pig housing. From the book, Rural Structures in the Tropics, Design and Development. The subject of this book is the exploration of rural infrastructures and services within tropical areas. While the text primarily addresses a special focus on Eastern and Southern Africa, the underlying principles are applicable across a broad range of tropical regions, although with necessary adjustments to accommodate local conditions.
The scope of the book is relevant to this assigned topic includes the following aspects shown below: planning farm and rural structures, graphical techniques, geospatial techniques, construction materials, basic mechanics, structural design, elements of construction building production. Despite being less important in most regions of Africa, pig farming for meat production and valuable byproducts is expanding in many tropical countries due to increasing market demand and a quick return on investment. These animals, primarily raised for meat, also provide economically valuable byproducts like skin, bristles, and manure, and can consume human food waste, thereby competing with humans for food to some extent.
Management improvements. In numerous tropical countries, pigs are often free-roaming scavengers or backyard raised, relying on waste for feed. Despite minimal efforts towards maximizing productivity, implementing a few basic management strategies can enhance their health and productivity. They include 1. Fenced paddocks provide shade and water to protect pigs from sunburn and overheating, while also allowing for supplementary feed and disease control. They can be subdivided for rotational grazing and selective breeding. 2. Simple semi-covered pens made of rough timber with a thatched roof and concrete floor, or earth floor, can house pigs efficiently. However, cleaning may require substantial labor. 3. Wallows or sprinklers can help pigs cool off in hot weather, as they cannot sweat and rely on wallowing for cooling. While these enhancements offer cost-effective building options and reduce the necessity for balanced feed diets, they should be viewed as initial advancements toward modernizing existing primitive systems. Confinement pig farming is gradually replacing traditional methods due to reduced production expenses, enhanced feed utilization, and superior disease and parasite management.
The confinement system is therefore usually advisable in circumstances shown below. Good management is available, high-quality pigs are introduced, farrowing occurs at regular intervals throughout the year. Land is scarce or not accessible all year. Balanced rations are available. Labor is expensive. Parasite and disease control is necessary. The target is commercial production. The herd size is reasonably large.
Some systems partially confine their herds. The typical order of priority for confinement housing for various classes of animals is as follows. In this literature, there is no standard type or system of housing for pigs. Instead, pig housing varies based on management systems. However, most systems share similar principles due to housing pigs of different ages and classes, as shown in Figure 10.26.
Farrowing suckling pens. In small to medium-scale intensive pig production, a unified farrowing, suckling, and rearing enclosure is normally used. Sows are introduced to this environment about 1 week before farrowing and remain there with their offspring for 5 to 8 weeks until weaning. Farrowing crates are commonly employed to minimize piglet mortality due to overlaying or trampling. Early weaning, occurring after a suckling period of 5 to 6 weeks, is advisable only under good management and housing conditions. Post-weaning, piglets typically stay in the farrowing pen until they reach 12-14 weeks of age or attain a weight of 25-30 kilograms.
While group housing of farrowing, suckling sows is feasible, it is uncommon in intensive setups. However, acceptance issues are minimal and litters freely cross-suckle and interact. Adequate space provision, including at least 6 square meters of bedding per sow and an additional 1 meter creep area, is essential. In larger-scale operations with separate farrowing facilities, alternative systems may be employed. In the first alternative, piglets are transferred to a weaner pen 2 weeks post-weaning, where they remain until they reach 12 to 14 weeks of age or 18-20 weeks of age. Transitioning piglets from the farrowing suckling pen to weaner pens should involve a 1 to 2 week adjustment period to minimize stress. These pens may accommodate 1 litter or 30-40 pigs and often feature ad libitum feeding.
The second alternative, System 4 in Figure 1027, involves placing the sow in a farrowing crate within a small pen 1 week before birth, then relocating the sow and litter to a larger suckling pen 2 weeks post-farrowing. Piglets may remain in this pen until 12-14 weeks of age, or are transferred to weaner accommodations 2 weeks post-weaning.
After weaning, sows typically enter estrus within 5 to 7 days and subsequently at 3-week intervals until successful mating. The weaning to conception interval ranges from 8 to 20 days depending on management practices. For mating success, sows are ideally housed in pens adjacent to boar facilities. During gestation, sows are grouped in yards or pens, typically consisting of 10 to 12 individuals expected to farrow within a 2 to 3 week time frame. Alternatively, they may be individually housed in stalls or tethered. Weaner and fattening pens. Weaned pigs, aged 12 to 14 weeks, transition to growing, finishing pens for further development. Finishing occurs either in a single stage, progressing from 25 kilos to 90 kilo, or in 2 stages. In the latter, pigs move from a smaller growing pen until they weigh 50-60 kilos, then to a larger finishing pen until reaching market weight.
In large-scale setups, pigs are grouped by size and sex upon entry into growing, finishing pens. While some operations house pigs in groups of 30 or more, better growth performance is observed in groups of 9 to 12 or fewer in intensive systems. An alternative method involves initially placing about 12 pigs per pen and subsequently reducing the number to 9 during the finishing phase by selecting pigs based on size. In intensive pig farming, sows undergo several reproductive cycles before being culled due to infertility, low productivity, or age. Young breeding stock is separated at 3 months for optimal feeding. Gilts are bred at 7 to 9 months, or 105 or 120 kilos. After mating, they're housed together until a week before farrowing or kept separately. Boars in the tropics remain calm when housed with others but may become aggressive if isolated. The objective in planning a pig unit is to balance the accommodation for varying pig ages and numbers. Ideally, each pen should maintain full occupancy, with a 7-day cleaning and sanitation interval between successive groups. In the given example of a 14-sow herd practicing 8-week weaning, the required number of pens will be determined.
The example highlights that determining the requisite number of pens and stalls in a pig unit depends on multiple factors, precluding strict regulations. Nonetheless, Appendix 6 provides guidelines for pen requirements in herds with satisfactory management and performance under tropical conditions. In intensive pig production systems, concrete floors are important for maintaining cleanliness and hygiene. Semi-intensive systems may employ concrete floors in finishing and farrowing pens while using earth floors or deep litter bedding elsewhere. Although concrete floors incur higher costs, reducing floor area per animal to cut expenses can lead to detrimental effects such as decreased performance, increased mortality, and health issues. Higher stocking densities necessitate enhanced management standards and improved ventilation and cooling. Notably, pigs in warm climates require more resting space for effective cooling. Recommended space allowances per animal at various stocking densities are provided in Table 10.9, with figures for high stocking densities applicable mainly in cooler regions and under superior management. Pen dimensions for fattening pigs are primarily determined by trough length requirements, listed in Table 10.10, though wider pens with low stocking density may increase the risk of manure accumulation.
Additionally, this enhances pen versatility, with surplus trough space enabling temporary accommodation of additional animals or adjustment as management standards improve. Deliberate overstocking may occur in finishing pens, as not all pigs reach market weight at the same time, allowing space utilization by remaining pigs. However, this practice is advisable solely in highly proficient finishing units. General requirements for pig housing. A suitable location for a pig unit necessitates proximity to an accessible, all-weather road, well-drained terrain, and ample distance from residential areas to mitigate odor and fly disturbances. An east-west orientation is typically preferred to minimize sun exposure, with favorable breezes enhancing ventilation. Ground cover like bushes and grass can mitigate heat, so selecting a site benefiting from surrounding vegetation is advantageous. Open-sided structures are recommended for maximum ventilation, often comprising a roof supported by poles, strategically placed to minimize obstruction. In some cases, solid gable ends and one enclosed side may provide shelter from wind or cold, with temporary walls feasible for seasonal adjustments. Adequate shade provision is paramount, achievable through high buildings with wide roof overhangs and shaded ventilation openings along the ridge.
Roof materials such as white paint or reflective metals help reduce solar radiation, while thatch can enhance microclimate but may pose fire hazards and attract pests. Proper construction, including concrete floors with appropriate slopes for drainage, is essential for hygiene and maintenance. Tight-fitting doors and minimal wall openings deter vermin intrusion, crucial for feed security and disease prevention. Housing for a small-scale pig unit. For units with 2 to 15 sows, specialized buildings for the various stages of production may not be practical or desirable. For the smallest units of 2 to 6 sows, a kind of universal pen can be erected about 2.7 meters wide and 2.8 to 3.0 meters deep, including feed trough, which can be used for 1. One sow and her litter, or 2. One litter of weaned piglets, or 3. Up to 4 gestating sows, or 4. Growing finishing pigs up to 90 kg live weight or 1 boar.
The pen in Figure 10.28 offers flexibility, but may not maximize building space like specialized pens. Farrowing modifications like guardrails reduce piglet losses. Exercise yards for sows are optional, but confinement during suckling is typical. Creep areas with temporary ceilings provide warmth for piglets. Figures 10.29 and 10.30 depict single-row and double-row pig units with semi-covered manure alleys for waste management. Roof gutters aid rainwater drainage or collection for pig drinking water. Additional security measures, such as rails, enhance safety without impeding ventilation. Both designs can expand by adding fattening pens alongside farrowing pens.
Housing for a large-scale pig unit. Efficient health control in large-scale units means limited animal density, age-based grouping, thorough cleaning between batches, and spaced buildings with fencing. Specialized pens for each production stage, feasible in units with 20-30 sows, maximize space use without layout constraints. The farrowing pen in Figure 10.32 confines the sow in a crate during farrowing. After 5 to 10 days, the crate is removed. Alternatively, a farrowing pen with narrow creep areas before farrowing reduces space needs. After 2 weeks, sow and piglets move to a suckling pen, like Figure 10.32b.
Growing, finishing pens, sized at 2.8 mm wide by 1.9-2.2 mm deep, with a 1.2 mm manure alley, can house pigs by weight, up to 40 kilos, 12 pigs, 40-90 kilo, 9 pigs, over 90 kilo, 7 pigs. In hot climates, reducing pig numbers is wise. Proper drainage, preferably covered, prevents urine flow between pens. Bedding reduces stress. Controlled feeding enhances feed conversion. Gestating sows, the last group for confinement housing, improve production efficiency when managed during gestation. After weaning, they return to adjacent gestating sow structures for heat detection ease. Sows are regrouped based on expected farrowing dates. Figure 10.33a depicts 4 sows per group, with 0.60-0.75 meter wide stalls.
Alternatively, Figure 10.33b accommodates variable group sizes, with sows expected to farrow within 10 to 15 days of each other. Feeding stalls are 50 cm wide, with a lowering bar to prevent interference. A manure alley with gating allows for easy cleaning, with adjustable width for tractor-mounted scrapers. Exercise yards may be feasible behind both types of pens. The spray system benefits all pig categories except very young piglets. In the farrowing pen, activating a sprinkler in the manure alley when the litter is about 2 weeks old helps maintain the sow's feed intake. It is much more effective than hosing pigs once or twice daily. Efficient pig production needs steady water and feed for balanced diets. Various feedstuffs, including byproducts, can be used. Feed needs change with pig growth and sow production stages. Table 10.11 estimates storage needs for meal feed mixes. Feeding equipment, like concrete or metal, prioritizes easy cleaning. Concrete troughs, often prefabricated with metal molds, are commonly placed in the pen's front wall for easier feeding, as shown in Figures 10.35df. Though more challenging to construct than interior placement, it's preferred. An open front enhances ventilation but is costlier due to needing galvanized steel pipes. A sloping front deters pigs from stepping into the trough, but is costlier. Figure 10.36 shows 2 piglet feeders suitable for the creep area, extendable for growing pigs up to 40-50 kilo, with metal preferred for durability, though wooden feeders suffice with regular cleaning.
Table 10.11 outlines water needs. Feed meal should be mixed with 1.5 to 2.1 liters of water per kilogram. Clean water must be available at all times, including for piglets in farrowing pens. Automatic drinkers are the most hygienic and ideal, with piped water ensuring hygiene. One type sprays above the feed trough when triggered by pigs, while the other activates as pigs bite. The latter, often in the manure alley, prevents wetting the resting area.
Manure handling. The pig pens need daily or bi-daily cleaning. With ample bedding and separate urine drainage to a storage tank, solid waste can be stacked on a concrete slab. Alternatively, if minimal bedding is used or urine is not separated, a manure storage slab, as in Figure 10.22, is suitable. Table 10.12 indicates manure production rates.
Additionally, this topic explores swine, pig housing, specifically focusing on the Philippines and taking into account its unique geography, climate, swine characteristics, physiological factors, etc. It introduces the Philippine Agricultural Engineering Standards, PAEs, 401-2000, in which the students of this group chose 3-unit system design for its representation, guided by the illustration shown in the video.
This 3-unit system design adheres to the standards, including space requirements, feeding, and watering facilities, ensuring that the swine housing is suitable for the local conditions and meets the welfare needs of the pigs. The design process takes into consideration various factors such as the ceiling height, which is recommended to be 2 m or high, and the building sidewalls, which have a minimum height of 1 m. These standards are important in ensuring the health and productivity of the swine population in the Philippines. Thank you for watching.